Hi guys, I haven't shown for a while. Since then we have brought some new functions to LinuxCNC Features. So mostly we were focused on Lathe and some subroutines concerning the Lathe. So let me show you what have we got over there. I have a LinuxCNC configuration that is configured for the Lathe and LinuxCNC Features panel to the right of the Access panel with Lathe catalog in it. So mainly there are some few features that we think should be widely used. So it's cutting, outside diameter, inside diameter, facing, taper, and threading. So I think it's the four most used features. So let's try to do some machining to get how does it work. So let's make a machining of the ball screw end to fit the ball screw support unit. So let's pretend that we have a ball screw with 16th millimeter diameter, and we need to machine it in this way on our lathe. So what are we going to do? First of all we will try to take this face off. So add a facing feature. In the parameters, Z we'll put it at 0. So let's make our face at 0 point on Z. Yep. And D0, it's a final diameter. Let's refresh it. Okay, we got a facing trajectory. Then we're gonna need to make this diameter. So let's make OD. This diameter is F and B 10. Diameter should be 10. Yep, that's it. And the length is 15. 15. Auto refresh. I'm gonna add auto refresh to see the results right out here. So there are two additional parameters. The Z is the starting point of the Z. So this means that we start at the very same point we end the previous machining. So usually we left it unchanged. D1 can be used to make a taper, but here if we use this parameter it will be the same as the D0. So as we can see, there's a lot of passes over here. Let's do some changes to this. We'll add set cutting parameters feature. Put it on the top to make it influence our other features that are on the bottom. Oops, sorry, that's in Russian, but you should have these features in your local, so it's already translated to some things are already translated to Russian. So what do we have here? It's a global surface, it's a surface where we start our machining. Surface for inner diameters, global depth step, feed, spindle, global rapid distance, and so on. So these parameters are set in the defaults file, and we can change it over here as we want. They are named here like global something, global surface, and so on, to make it able to change only one parameter and left others unchanged. So if we do add some other lathe cutting parameters, they will be unchanged unless we define something other than global rapid, for example, parameter. So let's try to do it. We'll define global surface. As we have ball screw diameter at 16 millimeters, let's define it. Okay, we got 16 millimeters. And we can see that the machine trajectory is changed in real time because we have auto refresh over here. Then we can change, for example, the depth step to something quite bigger than that. So we have two steps, and for example, the final cut, let it be 0.4 millimeters. As we can see, this almost only the final cut because the surface is 16, the depth step is 5, and it's 10 millimeters diameter. So let's make it, for example, 2 millimeters. So you can see 2 or 3 machine in full depth and 3 final cuts, 1, 2, 3. So right here we can adjust some additional parameters for the final cut, for example, spindle speed or feed or whatever. So let's continue. Now we have this face and this diameter. Let's go to the next diameter, this one. It's longer, it's for the bearings. So the length of it is 39 and diameter is 12. Okay, add another output diameter. As you can see, we are starting from the very same point we ended last machining. So we add here 12 as the diameter and length 39. Okay, almost done. We can add, for example, a facing over here to make, I don't know, some stair to hold the bearings. So add facing, just set up the diameter, end of diameter, for example, 11. So we got this face. There's a little bit depth over here at the end. So let's try to add the thread over here. Here we can add threading cycle. Let's see what we got here. 3 diameter. Okay, here it should be 12. Oops. Sorry, 12. Okay, thread pitch is 1 millimeter. And we want to put it into correct position. So starting point is from here, it's minus 15. And as we will be cutting it from right to left, the length should be less than 0. So it is 14, minus 14. So as you can see there, this taper on the thread. So if you want to change these parameters, we can always use threading parameters. Oh, we got inside threads over here, so it's a separate feature. So we can add threading parameters. Put it on the top over the lathe thread, and we can adjust another parameters of the threading. So for example, we want to get rid of this taper. Over here we can see it in the tooltip. So we want the taper only for exit. L2. Make it 2. Okay, so and we got taper is only on the exit. By the way, I think we should change something over here to make the thread starting from a little bit behind of this diameter. So let's make it -10, and here we should add something -19. So it's our thread. So we almost finished our machining. If you want, we can save this machine to be used afterwards, or for example to import to existing machining. So just press save, save as dialog. I don't know why, but if something is fixed on the top, the dialogs are shown on the behind. I don't know what's this, why is this happening. So we don't need it anymore. So for example 1605 XML, and now we have it saved, and we can for example import it from the file. So we get another one, threading and machining, or we can group it together and give these names to make it easier to understand what is going on over here. So add group, codes grouping, just a group. So, sorry, again in Russian. Put it on the top, no, on the bottom, and put all the things into the group. Yep, and here we can pick a name, for example, ball screw BK12. So it's almost it. Can save it again. Ball screw, okay, over here. Yep, and we are finished. Now let us see how does it work, and play. Yep, make a face. I've got a G64 over here, so we got a riddle blendy path. Let's change it. G64P. So just like this. Okay. Play. Yep, it's better. Yes, got one full cut, second, third, and now we should go into the final cuts with a small feed. Yep, as you can see, the feed is less than the previous cuts. So what we are going to do right now, what we need from you right now, we need somebody who can test these things, maybe test it on real machines, and we need your comments. What do you like, what do you don't like, what do you think we should change over here. So thank you for watching, and we'll be waiting for your comments. Thank you.